And welcome to our class. We are still talking about the Cauchy sequence. In today's class, we want to prove that the sequence sign of the reciprocal of numbers is Cauchy. We recall that by definition, a sequence is said to be Cauchy if for every epsilon greater than 0, there exists a p belonging to the set of natural numbers such that the absolute value of a sub m minus a sub n is less than epsilon for all mn greater than p. So the first thing we have to do is to determine p. We begin by using a sub m minus a sub n. Our a sub m will be the sign of the reciprocal of m, and a sub n, as we are given in the question, is a sign of the reciprocal of n. Therefore, a sub m minus a sub n will be equal to sine 1 over m minus sine 1 over n. And this is equal to the sine of 1 over m plus the sine minus sine 1 over n. And by the time we break this down using triangle inequality, this is less than or equal to sine 1 over m plus the absolute value takes care of the minus, and we have sine 1 over n. But recall that the absolute value of sine x is less than or equal to the absolute value of x. Therefore, the absolute value of sine 1 over m will be less than or equal to 1 over m, and the absolute value of sine 1 over n will be less than or equal to the absolute value of 1 over n. That implies that a sub m minus a sub n is less than or equal to the absolute value of 1 over m plus the absolute value of 1 over n. And so this is less than 1 over m plus 1 over n. Let 1 over m be less than epsilon over 2, and 1 over n be less than epsilon over 2. Therefore, m will be greater than 2 over epsilon, and n greater than 2 over epsilon. And since m and n is greater than p, it further implies that p will be greater than 2 over epsilon is our p, and we have been able to determine p. We then go ahead to prove. We then go ahead to prove. Let epsilon be greater than 0, and let p be such that p is greater than 2 over epsilon. Therefore, the absolute value of a sub m minus a sub n, which we have said is what? The absolute value of sine 1 over m minus sine 1 over n, and that is less than or equal to, using triangle inequality as we did here, sine 1 over m plus sine 1 over n, and that is less than the absolute value of 1 over m plus 1 over n, and that is less than 1 over m plus 1 over n. Therefore, the absolute value of a sub m minus a sub n will be less than 1 over p plus 1 over p. Since m and n is greater than p, but recall that we have chosen our p to be greater than 2 over epsilon. Therefore, a sub m minus a sub n will be less than 1 over 2 over epsilon plus 1 over 2 over epsilon, and that is less than epsilon over 2 plus epsilon over 2, and that is less than epsilon. Therefore, a sub m minus a sub n is less than epsilon, which implies that the sequence sine of the inverse of n, sine 1 over n, is a Cauchy sequence. We check also for cos 1 over n in our next example now, and determine whether cos 1 over n will also be Cauchy. As example 2, we want to prove that the sequence cos 1 over n is Cauchy. Just as the same way we have proved this, we will also prove, but as I usually say, the first thing we need to do is to recall definition of Cauchy. For every epsilon greater than 0, there exists a p belonging to natural numbers such that a sub n minus a sub n is less than epsilon for all mn greater than p. A sub n will be cos of 1 over n, and a sub n will be cos of 1 over n. Therefore, a sub n minus a sub n will be equals to cos 1 over m minus cos 1 over n. And by trig identity, we recall that cos A minus cos B will be minus 2 sine A plus B over 2 into sine A minus B over 2. Therefore, that implies that A sub n minus A sub n will be equal to the absolute value of minus 2 sine 1 over m plus 1 over n over 2 sine 1 over n plus 1 over minus 1 over n over 2, using that trig identity. And so what do we do from there? We recall that the absolute value of sine x is less than or equal to the absolute value of x. And that absolute value of sine x is less than or equal to 1. So what happens there? A sub n minus a sub n becomes, the absolute value takes care of the minus. We are left with 2 sine 1 over m plus 1 over n over 2 into sine 1 over m minus 1 over n over 2. If we use these 3 asterisk for the first one, we have 2 into the absolute value of 1 over m plus 1 over n over 2 into, and then for the second one, the absolute value of sine x to be less than or equal to 1. So we take this to be less than or equal to 1. And then 2 cuts that. That is less than 1 over m plus 1 over n. Again, we take 1 over m to be less than epsilon over 2, which gives us m to be greater than 2 over epsilon, and also 1 over n to be less than epsilon over 2, which gives us our n to be greater than 2 over epsilon. Therefore, since m and n are greater than p, our p will be greater than 2 over epsilon. Having determined p, we can now go ahead to prove. We are proving let epsilon be greater than 0 and p be such that p is greater than 2 over epsilon. Therefore, a sub m minus a sub n will be equal to cos 1 over m minus cos 1 over n. And remember that we used the trig identity the first time. Using the trig identity, and what is the trig identity that we used? Cosine A minus cosine B is equal to what? Minus 2 sine A plus B over 2 into sine A minus B over 2. Therefore, using the trig identity there, we have A sub m minus A sub n to be equal to the absolute value of minus 2 sine 1 over m plus 1 over n over 2 into sine 1 over m minus 1 over n over 2. The absolute value takes care of the minus. We have minus 2 sine 1 over m plus 1 over n over 2 into sine 1 over m minus 1 over n over 2. Remember, we said the absolute value has taken care of the minus. So what do we have? We are coming back here. So making use of that identity, it implies that the absolute value of a sub m minus a sub n will be equals to 2 into the absolute value of sine 1 over m plus 1 over n over 2 into sine 1 over m minus 1 over n over 2, also in absolute value. Therefore, this is equal to 2. Using the first identity, we have 1 over m plus 1 over n all over 2 into 1, using the second identity. And so this takes care of that. It becomes less than 1 over m plus 1 over n. And since mn is greater than p, this becomes less than 1 over p plus 1 over p. But recall that we have said our p is such that p is greater than 2 over epsilon. Therefore, this is less than 1 over 2 over epsilon plus 1 over 2 over epsilon. And that is less than epsilon over 2 plus epsilon over 2, which will be less than epsilon. That is, a sub n minus a sub n is less than epsilon. Therefore, the sequence cos 1 over n is Cauchy. If you have gained anything from today's video, give it a thumbs up, like, and share with your friends and colleagues. Thank you. God bless you. I see you in the next video.